Number one, the graph of f of x is shown below. So here's the graph of f of x. Okay, letter A, determine whether it represents an odd degree or an even degree polynomial. Okay, so here we have two odd degree polynomials, whereas here we have two even degree polynomials. An even degree polynomial opens in the same direction. So see how here it opens up, okay? If you look at the left of the graph and the right of the graph, in both directions the graph is opening up. And here, if you look at the function, you see that it's opening down as you look to the left, and as you go to the right on the graph, you'll see in both directions it's opening down. When they open in the same direction, it's going to be an even degree function. Okay, now an odd degree function opens in opposite directions. So if you'll notice here, to the left, it's going down, and as you go to the right on the graph, it's opening up. All right, so as x approaches negative infinity, it's going down, and as your x approaches positive infinity, it's going up. Okay, same thing here. When you go to the left on your graph, this arrow is pointing up, and when you go to the right on your graph, this arrow is pointing down. So an odd degree function opens in opposite directions, like these, and an even degree function opens in the same direction, okay? This one's opening up, this one's opening down. So if we look at this given function, we could see as the x values get smaller and smaller, okay, as we go to the left on our graph, the graph is continuing to go down, okay? And as we go to the right on our graph, as our x values get bigger and bigger and bigger, we'll see our function is opening up. So since these are opening in different directions, it's going to be an odd degree function. Letter B, determine the sign of the leading coefficient. Is it negative or positive? Okay, so if we have let's start with an even degree function. Let's start with what this isn't. If we have an even degree function, if it opens up, it has a positive leading coefficient, okay? If it opens down in the negative direction, it has a negative leading coefficient. So that's pretty easy, okay? It makes sense. It's opening in the positive direction, it's a positive leading coefficient. It's opening in the negative direction, it has a negative leading coefficient. Now with odd degree functions, if you look, as you go from left to right, what you'll notice is this function over time is going up. Okay, if it's going up over time, then it has a positive leading coefficient. For an odd degree function that starts off, that not starts off, but that winds up going down as the x values increase, that's going to have a negative leading coefficient. Now, to be honest, you can really just look at what the graph is doing as you go to the right, okay? See how this, as you go to the right, is going up, and this, as you go to the right, is going up? That's what gives us a positive leading coefficient, whether it's odd or even. Okay, now here, if you look at what it's doing as we go to the right on our graph, as the x values get bigger, this is going down. And same thing here, as you look, as the x values increase, the y values are decreasing. Okay, this graph is going down. So when you look to the right, if it's going down, it's a negative leading coefficient, and if it's going up, it's a positive leading coefficient. So let's look at our graph. As we look to the right, we'll see this is going to continue to go up and up and up, so it has a positive leading coefficient. Okay, you can see it's going up over time, so it has a positive leading coefficient. Okay, letter CS is to determine the number of relative maximums. Now, I mean, to be honest, if you're looking for a relative maximum, you're really just looking for kind of like the top of a bump, which you could see here and here. Whereas if they were asking for the relative minimums, you can see right here is the point where the graph reaches a minimum before it starts heading back up again. And we have another relative minimum right here. Okay, so we have two relative maximums and two relative minimums. So it's basically just the maximum point within a particular interval, or the minimum point within a particular interval. So here to answer the question, we have two of them. Okay, and then letter D, describe the end behavior of the graph. Okay, so we're always going to start it off the same way. As x approaches negative infinity, f of x. You may use y in certain cases, but here we're looking at f of x, so make sure you use, whatever the function notation is. So as x approaches negative infinity, what that means is as your x values get smaller and smaller and smaller, so as your x values get smaller and smaller, what we're doing is we're going to the left. along the x-axis. So basically, as you go to the left, what is your graph doing? Well, you can see the further left you go, the graph is going down. So we can fill in here, f of x is going to approach negative infinity. If it goes down, it approaches negative infinity. Okay, now, the next thing we say is as x approaches positive infinity. So what that means is as the x values get bigger, as you go to the right on your graph, what's happening? Our function is increasing and increasing. It's getting bigger and bigger and bigger. So when something gets bigger, it's approaching positive infinity. Okay, number 2, which statement about the function is incorrect? Okay, make sure you look if they say incorrect or correct. All right, choice 1. There is one relative maximum and 2 relative minimums. Well, this is true. If we look, we do have one relative maximum and we do have 2 relative minimums. So this one's true. Okay, we want to know which is incorrect. Choice 2. As x approaches negative infinity, so as we go to the left on our graph, does y go up? Does the graph go up? Does y get bigger? So as we go to the left on our graph, does the graph go up? Does it increase? Yes, it does. So that's true. As x approaches positive infinity, so as we go to the right on our graph, does y get bigger? Does the graph go up? Yes, it does. So this is true as well. Okay, choice 3. The degree of the polynomial is even. Yes, if it opens in the same direction, see how it's opening up on the left and on the right of our graph? That means it's even. It's only odd if it opens up in opposite directions. Okay, so this one is true, so choice 4 must be the answer, but let's just read it to make sure, because you don't want to, you might have made a mistake somewhere above. There is a negative leading coefficient. All right, that's the true statement. If an even degree function has a negative leading coefficient, it would be opening down, and as you can see here, this graph is opening up. So choice 4 is the answer. Number 3, if there is a repeated root for a polynomial equation, which of the following occurs at the x-axis of its graph? All right, so let's talk about that. If you have a repeated root, what's going to happen is the graph is going to touch the x-axis, and it's just going to bounce right off. So for example, it's going to do something like this, okay? It's going to touch it and just bounce right off. All right, so if we read the answer choices, choice 1, the graph bounces off the x-axis. All right, there it is, choice 1. Number 4, the graph of g of x is shown below. Determine an equation for g of x. Okay, so in order to determine an equation, first thing we want to do is we want to look at the zeros, because that's going to help us find the factors. So we can see that we have a 0 right here at x equals negative 2. We have a 0 right here at x equals negative 1. And we have a 0 right here at x equals positive 2. Okay, so when we go to write our equation, we could first write g of x equals. Now, we don't know what the leading coefficient is at this point, so I'm just going to call that c. And then the factor that goes along with a 0 of x equals negative 2 would be x plus 2. And the factor that goes along with the 0 of x equals negative 1 would be x plus 1. And then the factor that goes along with this 0 of x equals positive 2 would be x minus 2. But be careful with this one, because this one, whenever your graph bounces off the x-axis like this, okay, it doesn't go through it like these ones. What that means is we have multiplicity of 2. So we're going to have to put a square on this factor. All right, so that's the first step. Now, we can't leave our equation like this because we need to determine this leading coefficient. Okay, so what you can do is you could pick any point on the graph other than your x-intercepts. So I'm actually going to pick the y-intercept right here. So the coordinate of that y-intercept would be 0, negative 8. So 0 is representing the x value, and negative 8 is representing the y value. Okay, so let's take the 0 and the negative 8 and substitute it into our equation here. Now, since g of x means the same thing as like y equals, I'm going to substitute the negative 8 in for g of x. And then I'll bring down the equals c. And then our x here is 0. So wherever we see an x in this equation, we can replace it with a 0. Okay, so after we do that, we're going to solve for c. Okay, so to do so, let's bring down the -8, the equals c, and then just 0 plus 2 is 2. 0 plus 1 is 1. And 0 minus 2 is -2. And when you square a -2 times -2 is +4. All right, so now I'm going to, again, bring down the -8 and the equals c, and then 2 times 1 times 4 is 8. So to get the c by itself, all we have to do is divide both sides by 8, and -8 divided by +8 is -1. So that's our value of c. So what we're going to do now is just take this -1 and replace it for c into the original equation. All right, and there we have it, okay? And if you wanted to check, you could always go to y equals in your calculator and plug in this equation that you created and see if the graph looks like this. See if the points from your table of values matches up with these points that we have here. Number 5, which equation could represent the graph below? Okay, so let's look at the zeros. Here we have a 0 at x equals -2, which means we'd have a factor at x plus 2. Okay, we have a 0 here at x equals 1, which means we would have a factor at x minus 1. And here we have a 0 at x equals +3, which means we'd have a factor at x minus 3. Okay, so if we look at these answer choices, we could see that none of them look exactly like what we have here. But if you look at the first one, it says x minus 2. We don't have an x minus 2 as any of our factors, so it definitely can't be choice 1. Okay, choice 2 has an x plus 2, which we do have. Choice 3 has an x minus 3, which we do have. And choice 4 has an x plus 3, which we don't have. So we could already eliminate choices 1 and 4. Okay, so let's just go through the answer choices. If we have an x plus 2 as one of our factors, then what this is saying is if we multiply out our other two factors, we should wind up with this if choice 2, if this is the graph of what choice 2 is demonstrating. So let's bring down this x plus 2, and let's double distribute. Okay, so that gives us x squared minus 3x minus x plus 3. And then I'm going to bring down my x plus 2. And when I combine my like terms, I get x squared, and then the -3x and the -x combine to give us -4x. And I can bring down the plus 3, which, oh, look at that. That actually does match up with choice 2. So choice 2 is our answer. Now, if you want to, you can try with choice 3. You can, basically, here's the x minus 3. You can multiply together the x plus 2 and the x minus 1 to see if this is what you get. But you won't. Okay, what's going to happen is you'll get something similar to it, but when you multiply out the x plus 2 and the x minus 1, you'll have a plus x instead of a minus x. So choice 3 doesn't work either. All right, so number 6, which of the following has a factor of x plus 8? All right, well, I feel like the easiest way to do this is if we know that there's a factor of x plus 8, then what we know is that there has to be a 0 at x equals -8, which means the graph is going to cross through the x-axis at -8. So I would just go to y equals in my calculator and graph these one at a time and see which one crosses through the x-axis at -8. All right, so it looks like when you get down to choice 3, this is what our graph looks like. Okay, and it's crossing through. You can see on your calculator, it's crossing through the x-axis at -8. So this would be our answer. I mean, another way you can do it is you could do it algebraically. If x equals -8, what that means is when you substitute -8 in for these x's, the function will be equal to 0. Okay, so like if you took choice 3, I'm just going to jump right to the answer. So where we see f of x, I'm going to substitute that x with a -8. So if I wrote f of -8 equals, and then I'm going to replace all these x's with -8s. This is definitely the longer way to do it. I would just do it graphically, to be honest. plus 15 times negative 8 minus 8. If this expression right here is equal to 0, then that means negative 8 is a 0. So you can either plug this all into your calculator, or you can do it by hand. Okay, so let's see. Negative 8 squared is 64, and 64 times 2 would be 128. And then 15 times negative 8 would be negative 120. And I'll bring down the negative 8. So actually, yeah, look, this does equal 0 because 128 minus 120 would be positive 8, and 8 minus 8 is 0. Okay, so because this equals 0, that means that negative 8 is a 0, so x plus 8 is a factor. Number 7 asks us to factor the following expression. Okay, so the first thing we want to do is we want to look at this and say, do we have a greatest common factor? Well, since all of these numbers are even, we can definitely pull out a 2. So let's start off by doing that. And that would leave us with 6x squared minus 19x plus 10. Okay, so now, even though we pulled out a greatest common factor, we still have a number other than 1 in front of the x squared. So what that tells us is we're going to have to do the rainbow. Now, when we do the rainbow, this is when we don't set up 2 sets of parentheses, okay? This is where we're going to bring down the first term. I'm going to leave a big space because I have to fit 2 terms here, and then I'm going to bring down the last term. Okay, now let me bring down the parentheses and bring down the 2. Okay, so how it works is we need to come up with 2 numbers that multiply to the rainbow number, so 2 numbers that multiply to 60, and at the same time those 2 numbers have to add to negative 19. Okay, you may have to do a little bit of trial and error to come up with them, but all said and done, you wind up with negative 4 and negative 15. Now, since this middle term has an x on it, we need to put x's on these 2 terms. Okay, and now we're going to group. All right, so let me bring down the 2. I'm going to actually use a bracket instead of parentheses, just so, we can decipher the parentheses from the brackets. Okay, now out of these first 2 terms, I'm going to pull out the GCF, which is 2x. And that would leave me with, in parentheses, 3x minus 2. Okay, now when we look at these 2 terms, it looks like we could either pull out a positive 5 or a negative 5. So in order to be left with a positive 3x and a negative 2 in parentheses, we're going to have to pull out a negative 5. Okay, see how my signs here go positive, negative? Since these do the opposite, negative, positive, it tells me I have to pull out a negative here. So we're going to pull out a negative 5. Okay, so then negative 15x divided by negative 5 is positive 3x. And then positive 10 divided by negative 5 is negative 2. And I'll close up the parenthesis and close up the bracket. And if you look here, these match up. And that's what we want to happen. Okay, so we have one more step. I'm going to take this 2 and just bring it right down. Then I can take what's in front of our common parenthesis, our common binomial, and we can group those together. So I'm going to write 2x minus 5 in the next parenthesis. And let me bring down that common binomial, 3x minus 2. Okay, so that's factored for you. And remember, if you want to check your work, it's really easy. You plug this original expression into your calculator and hit enter. Then you plug your factored answer into the calculator and hit enter, and make sure they match up. The only thing you have to be careful of if you're checking in your calculator is your calculator won't tell you if this is factored completely, like can I factor further, can I do dots? But other than that, it'll tell you if this expression is equivalent to your final expression. Okay, now number 8 is different than number 7 because number 7 we just had to factor. So there was no solving. You were just factoring and done. This is asking you to determine the zeros, which means we're going to have to take this expression and set it equal to 0. Okay, so what we have to do is solve this. Now, if I was factoring, right, if we had to factor, we would factor out the greatest common factor, which is 2. But because this is an equation, rather than factoring out the greatest common factor, it makes your life a little easier just to divide both sides of the equation by that number. Remember, you can divide, an equation by any number you want as long as you do that, as long as you divide both sides of the equation by that same number. Okay, so when we do that, that leaves me with 1x to the fourth minus 17x squared plus 72 equals, and then 0 divided by 2 is just 0. Okay, so I just went through and divided everything by 2. Okay, so now from here we can factor further. Now, since there's a 1 in front of our x to the fourth, please, please, please don't do the rainbow, okay? Don't try to do that. Don't create 4 terms. If you have a 1 in front of your first term of the trinomial, we set up 2 sets of parentheses. And we're going to remember to bring down that equals 0 right here. Okay, don't forget this. You have to keep it in equation. And in the first spot right here, we're going to put an x squared. Since this is an x to the fourth, we're going to put x squared here and here. And then you're just doing AM. You're coming up with 2 numbers that add to negative 17 and multiply to 72. All right, so that's going to be negative 9 and negative 8. Okay, so you could do one of 2 things here. When you're solving, you really don't have to factor completely. You can just make a t-chart and solve. Or if you want to factor this further to x plus 3 times x minus 3, you can do that as well. I'm going to show you both ways. That way, you can see which way you like better. All right, so if you want to just jump right into the t-chart, what you can do is you can just set each factor equal to 0. Okay, so I'm setting the x squared minus 9 equal to 0, and the x squared minus 8 equal to 0. And then I'm just going to solve these. So on this side, I would add 9, which leaves me with x squared equals 9. And when I take the square root, remember that this square right here tells us that we can have up to 2 answers. So in this case, we do have 2 answers, okay? It's going to be positive and negative 3. Okay, so plus and minus 3. Because if you put positive 3 back in here, 3 squared is equal to 9. And if you plug the negative 3 back in for x, negative 3 squared is also equal to 9. So they both check out. All right. Then on the other side of the t-chart, you really just solve it the same way. We're going to add 8 to both sides. And then again, we're going to take the square root. So a square and a square root cancel each other out, leaving you with x. Again, we have plus and minus. Now here's the difference. 8 is not a perfect square. But if you can simplify this radical, you are definitely going to want to do that. So radical 8 breaks down into radical 4 and radical 2. And then the square root of 4 is 2. So this becomes a 2, so it leaves us with 2 radical 2. All right, so we wind up with 4 answers. Positive 3, negative 3, positive radical 2 radical 2, and negative 2 radical 2. If you wanted to check graphically, you can go to y equals in your calculator and plug this in, and you'll clearly be able to see that the graph intersects the x-axis at positive 3 and negative 3. But 2 radical 2, I mean, if you were to just take that and round that in your calculator, 2 radical 2 is approximately 2.8. So you would see the graph crosses the x-axis at positive 2.8 and negative 2.8. And again, that's approximations. Okay, number 9 asks us to algebraically determine the zeros of f of x, just like we did in number 8, but then they want us to check our answers graphically, which I did talk about in number 8, how to do that. Okay, so first thing, if we want to determine our zeros, we need to set this right here equal to 0. Okay, now I know a lot of you, when you see one of these, are tempted to, rearrange so the exponents are in descending order, or even to combine your like terms. But more times than not, when the Algebra 2 Regents gives you an expression that contains 6 terms like this, they set it up so nice and neat for you. So, I would actually try to just jump right into grouping and see if that works. If not, then I would try to rearrange. All right, now I'm sure a lot of you guys can see this. You can either group it into 3 and 3 or into 2, 2, and 2. So if you look ahead, if you try to group it into 3 and 3, Try to visualize that, okay? Are you going to wind up, when you factor out the greatest common factor, with the same thing in parentheses? Well, no, you're not. If you're not sure, try it. Group these three, and pull out the greatest common factor. See if you're left with the same thing. It's not going to happen here. So if we were to group it into 3 groups of 2, oh, and by the way, please make sure when you group that you don't, I'm going to actually do something that I don't want you to do. Please don't do this. Don't try to put parentheses around your groups, because what does parentheses mean in math? Parentheses mean multiplication. We're not multiplying this binomial times this binomial times this binomial, okay? We're adding these terms right here, okay? We're adding these terms right here. So do not insert parentheses, because then you're saying, you know, we're doing multiplication. Okay, I'm actually just deleting all those. Okay, so let's do it. Out of the first 2 terms, we can pull out an x squared, which is going to leave us with x squared minus 4. Okay, out of these next 2 terms, we could pull out an 8x. So if I pull out an 8x, I'm writing plus 8x. I'm not just writing 8x. That also leaves me with x squared minus 4. Okay, and then out of these 2 terms, it looks like we could pull out a 12. So again, I'm not just putting, okay, if I just put 12, that's not right. We're adding on 12 times what we're left with, which again is x squared minus 4. Okay, and I'm going to take this equal sign and bring it down. I want to keep it as an equation. All right, so now let's take what's on the outside of these common binomials. Let's take the x squared, the plus 8x, and the plus 12, and let's group them together in one parenthesis. So x squared plus 8x plus 12. And then I'm going to take the x squared minus 4 and bring that right down. Okay, so now if you look, you could see that both of these can be factored further. Okay, this is a trinomial, and there are 2 numbers that add to 8 and multiply to 12, so that can factor further. And this right here is dots. Now, we saw in the last example that if you didn't want to factor dots further, like if you just wanted to set this factor equal to 0 and solve, you would get the correct answer. I'm going to factor this one further in this example, just so you could see that method as well. Right, so let me start off with this first parenthesis, the trinomial. So I'm going to set up 2 sets of parentheses. Since this is an x squared, I'm going to put an x on the first spot in each parenthesis. And then I'm just coming up with 2 numbers that add to positive 8 and multiply to positive 12. So positive 6, positive 2. Okay, and then this is just dots. It's a difference of perfect squares. So that would factor to x plus 2 times x minus 2. All right, now that it's fully factored, I'm going to make my t-chart. And we wind up with x equals negative 6, x equals negative 2. Now look, we have multiplicity here because we wound up with a repetitive factor, a repeated root, which we'll see when we graph that. Okay, at negative 2, the graph isn't going to cross through the x-axis. It's actually going to touch the x-axis and bounce right back off it because there's 2 of the same roots. Okay, and then under here we get x equals 2. So here we only wound up with 3 answers. I'm going to just kind of group them in curly brackets. Not that you have to do this. You could just, you could just circle this, this, and this. But we wound up with x equals negative 6, negative 2, and positive 2. So there's our 3 answers. Now this question says to check your answers graphically. Okay, so the reason why we're going to check graphically, I mean, you always want to check if you can. Okay, we want to see if we wind up with these 3 roots. And remember, the graph should cross through the x-axis at negative 6. It should cross through the x-axis at 2. And at negative 2, it should just bounce right off the x-axis because we have multiplicity. We have a repeated root. Okay, so as you can see, here's our graph. And we have a 0 at x equals negative 6, which matches with this. We have a 0 at x equals negative 2. And like we said, look, it's coming down and it's going to bounce off the x-axis. It's not going to follow through. It's not going to continue through because we have 2 of them. and there's another 0 right here at x equals 2. So the graph checks out. Okay, number 10. I made the question pretty small because I want to be able to fit some pictures on the screen. It says, during a basketball shot, the ball's height in feet will be a function of the ball's flight in seconds, which can be modeled by a quadratic function. All right, a basketball shot that is made from 6 feet off the ground with an initial velocity of 30 feet per second is represented by this function right here, h of t. Okay, this is its height in terms of its time. Express all answers to the nearest hundredth. Now, if you look through, they ask us a lot of questions having to do with the graph, the maximum height, what time will that happen? So I'm thinking the first thing we're going to want to do is go to y equals in our calculator and plug this in. The only thing is, instead of using x's, we're going to use, instead of using t's, we're going to use x's. And h of t really means the same thing as y equals. So we're going to plug this into y equals. Okay, so again, I went to y equals, and I plugged this in. Now, when I hit graph, this is what I saw. I mean, you can see here the basketball's going up, and it's coming back down, right? And this is where it hits the floor, I guess, because it's not going to have any negative height. Now, I'd like to see my graph a little more, so rather than leaving it like this, I'm going to adjust the window a little bit. So, I mean, the x-axis represents time. We don't need any negative time, so I'm going to set my window so that the x minimum is 0, right? There's no such thing as negative time. And it looks like it hits the x-axis a little bit after 2 seconds. So maybe I'll make my x max 3. Okay, so I'm going to make my x min 0 and my x max 3. Okay, and then my y min and y max, my y min, okay, the ball isn't going to go under the ground. It's going to hit the ground, and that's it. So we don't need any negative y values, so I'll make my y minimum 0. And I'm not actually sure how big to make my y max. I don't know how high this graph goes up. So let me look at my table of values. And it looks like the highest value this table shows is height at 20, but it could go a little higher than that, okay, just at the whole number x points, at the integer points. 20 is the highest that it hits, but it might go higher than that, in between 1 and 2, or in between, actually, it looks like here, 0 and 1. So I'm going to go a little higher than 20. Why don't I make that? You can make it 25, you can make it 30. I'm going to make mine 25. I think that's going to work out. Okay, so I've just matched up my min to 0, my max to 3, my y min to 0, and my y max to 25. Okay, you hit the window button. It's the second button from the left on the top in your calculator, okay? You adjust the window how you want. You could always go to Zoom and hit fit and see what the calculator does for you. You could fit it to what they think. But it's better if you, read the question, think about what's going on, and change the window yourself. All right, so let me hit graph now and see what we have. Okay, so this looks like it fits. So, we can see that letter A wants to know, find the maximum height the ball will reach. And it does say to express all answers to the nearest hundredth. So it looks like the maximum height is somewhere like right around here, but we're going to have to use our calculator to find it. Okay, so in the calculator, you're going to hit the second button and then the trace button, which is on the top right, second button from the right on the top. And since we want to find the maximum, we're going to scroll down to number 4 and hit maximum. Okay, now the calculator is going to ask you to put a left bound and a right bound around the maximum because your graph could have more than one max, right, if it keeps going up and down and up and down. Okay, so you can see here, I took a picture of it, that I just moved my cursor until it was, if this is the max, I'm going to move my cursor until it's somewhere to the left of that maximum, so somewhere over here. It'll say left bound, and then you just hit enter. Okay, so now the calculator is going to say right bound, so you're going to want to take that cursor and move it all the way until you're to the right of the maximum point, which you could see I am here. And then you're going to hit enter. And then it's going to say guess, you're going to hit enter again. Okay, and then finally, your calculator will give you this maximum point. See, once it says maximum, you know this is the maximum point. Now, when we look at this graph, right, since we're talking about the height of a basketball over time, we know the x-axis is our time axis, right? They're using t for time. And we know the y-axis, or in this case, the h of t axis, is the height of the ball. So in part A, when it says to find the maximum height, okay, we're looking for the maximum y value. So So the maximum y value is this one right here. And they want you to round to the nearest, what, hundredth? So to the nearest hundredth, that would be 20.06. And make sure you put your units, and you can see here we're talking about feet. Okay, so this would be feet. Okay, now letter B says find the time when the basketball first reaches the maximum height. So now we're looking for the time. So remember, the t-axis, the x-axis is our time axis, so this is the time that it happens. It actually takes less than a second to happen. If you round that, it's 0.94, okay? So this is going to give us our answer to letter B. So that would be 0.94 seconds. All right, so letter C, determine how long it will take the basketball to reach a height of 10 feet. Okay, we could do this algebraically or we could do it graphically. If we wanted to reach a height of 10 feet, well, we know that h of t stands for the height. So we can just replace this 10 in for h of t. Okay, so I'm going to do that. Okay, so again, we're solving for how long we're solving for the t it will take for the basketball to reach a height of 10 feet. So we plugged in 10 for the height, for the h of t. All right, so let's solve this. So I'm just going to use the quadratic formula. Since we have a quadratic, right, our biggest exponent is a square. Let's set one side of the equation equal to 0. I'm just going to move this 10 over. Since we're using the quadratic formula, it really doesn't matter that our leading coefficient is going to be negative. So here we have that negative 16 in front of the t squared. With the quadratic formula, it doesn't matter. With factoring, I like to have a positive there. Not that you have to, but I just feel like it makes it easier. Okay, so there's our equation. Now we're going to plug it into the quadratic formula. So let's see, that'll give me t, instead of x equals, we're going to have t equals. And don't forget to write this, okay? We're solving for t, so we're going to write that t equals. All right, so negative b. So here's, let me say this. The a is negative 16. The b is positive 30, and the c is negative 4. So we're going to have negative b, so negative 30, plus and minus the square root of b squared, so 30 squared. Since it's positive, you don't have to put it in parentheses, but if it was negative, you would have to. And then minus 4 times a, which is negative 16, times c, which is negative 4. And that whole thing's going to be over 2 times a, so 2 times negative 16. All right, so that gives us t equals. Now, you could do one of two things. You can plug the 30 squared into your calculator to give you 900, and then you can multiply 4 times negative 16 times negative 4. So you could do 900 minus that product, or if you prefer, you can plug this whole entire thing in your calculator at once. Okay, so, I just plugged it in my calculator all at once. So 30 squared minus 4 times negative 16 times negative 4. And keep in mind, these are negative signs. Don't hit the minus button in the calculator. Hit the negative sign. So it gives us 644. All right, so we'll have t equals negative 30 plus and minus. Oh, and keep in mind, I didn't plug the radical into my calculator. I just plugged what was under the radical because I'm still leaving the radical right here. All right, and then in the denominator, 2 times negative 16 is negative 32. All right, so now what we have to do from here, because they want us to round to the nearest hundredth, we just have to figure out what each of these are equal to. So if you plug in the calculator, negative 30 plus radical 644 over negative 32, you can see this is what we get. So the nearest hundredth, it would be 0.14. So let me branch that off. So we have t equals 0.14. And then if we do the same thing, but replace this addition sign with a subtraction sign, you'll see that this is what we get. So that would be 1.73 to the nearest hundredth. So t equals 1.73. Okay, so, we know from our picture there's actually 2 times, right? If we think about what this picture looks like, it looks something like this. There's 2 times when the basketball is going to reach a height of 10 seconds. Right here at 0.14 seconds, then it comes up and comes back down and then back again at 1.73 seconds. Okay, so for letter C, we have two answers. Now, some of you might prefer to do this graphically instead of algebraically, so let me go over that as well. Okay, and by the way, if you prefer the algebraic method that I just had up here, you could just fast forward past this. All right, so if you want to do this graphically, you should already have this first equation in y1, okay, because that's what's given to us. So we would have this under y1. Now, if we want to figure out when it's going to reach a height of 10 feet, we can also graph y equals 10. And we can look at where the two graphs intersect. All right, so your window should still be set up from part A and B. So let's hit graph and see what this looks like. Okay, I just sketched what I saw, but it should look something like this, okay? So there's 2 points right here and right here where the graph reaches a height of 10, okay? So if we want to figure out when exactly that happens, we want to figure out when does this line intersect this curve. All right, so in your calculator, you're going to hit the second button and then trace. Okay, that always brings us into calculate. We want to calculate something about the graph. Okay, and we're going to choose choice 5. We want to figure out again where this line and this curve intersects. All right, so now, because we have 2 points of intersection, you have to look at one at a time. So I'm going to take my cursor and move it over towards this first point of intersection. And then all you have to do is hit enter, 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 until you see the word intersection on the screen, and you'll see, look, it occurs right here at 0.14 seconds. So that's how we get the first one. Okay, then you're going to repeat the process. You're going to go back to second trace. You're going to go into calculate and again choose choice 5. You have to do this again. Okay, and this time we're going to try to find the second point of intersection. So let's move our cursor over by the second point of intersection. Okay, so once you move the cursor over here and hit enter, 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 look, you'll see it happens at 1.73, which is what we got for our second answer. Okay, and one thing I just want to point out, if you are going to do these graphically rather than algebraically, you do need to show the graph, a picture of a graph on your paper, and that way we know how you went about getting these answers. Okay, letter D, assuming it missed the basket, determine how long it will take for the basketball to reach the floor. Okay, so when the basketball reaches the floor, right, basically the height of the basketball, which we call h of t, would be equal to 0, okay, because it's 0 feet above the ground. So all you're going to do is I'm going to do this algebraically. I personally prefer algebraically, but you can do it however you want. I actually like to do it both ways and do a double check, but if we want to know when the height equals 0, we're going to replace h of t with 0 and just bring this side of the equation down. Okay, so our equation is already set equal to 0, so we can just plug it right into the quadratic formula. So we have our a being negative 16, our b being 30, and our c being 6. So instead of x equals, we have t equals. So t equals negative b, so negative 30, plus and minus the square root of b squared, so 30 squared, minus 4 times a, which is negative 16, times c, which is 6, and that whole thing is going to be over 2 times a, so 2 times negative 16. Okay, so I plugged this into my calculator right here, and you could see I got 1,284. Right, so that leaves us with t equals negative 30 plus and minus the square root of 1,284 over negative 32. And make sure this fraction bar extends under the negative 30 as well, okay? This entire numerator is over the denominator of negative 32. All right, now, technically you could try to break up this radical, but please don't bother. Don't take a chance of making a mistake. If they're telling you to round to the nearest hundredth, they're telling you you're going to have to plug this in your calculator anyway and round. So, honestly, I would just plug negative 30 plus radical 1284 divided by negative 32 in your calculator, and then do the same thing but with the minus sign and see what you get. Okay, so as you can see, when I plugged in the one with the addition sign, I wound up with negative 0.18 to the nearest hundredth, so t equals negative 0.18. And then when I plugged in the one with the subtraction sign right here, I wound up with, to the nearest hundredth, 2.06. So t equals 2.06. Now let's think about this logically. T is representing time. Time cannot be negative. You can't have negative time. So I'm going to cross this one off. And before I circle this one, I'm going to put my units. My units would be seconds. It would take 2.06 seconds in order for the basketball to reach the floor. Now, just in case you prefer to do this graphically, I will go over that as well. If you like it algebraically, then you can just fast forward past this next part. Okay, so in order to do this graphically, this is what our graph looks like. I mean, this is, again, just a sketch, but the ball is released. It goes up, totally misses the basket, and then comes down and hits the floor. So if we want to figure out how long will it take to reach the floor, we're looking for how much time has passed between here and here. So if we can find this zero, this x value of the x-intercept here, then we can figure out how long it'll take. Okay, so in order to do that, in your calculator, you're going to go to second trace, which brings you to calculate. And then it's going to ask you to put a left bound and a right bound around this zero. So you can move your cursor somewhere to the left of the zero. So I guess like it'll be like somewhere over here maybe. And then to get to the right bound, you're going to kind of have to scroll past this a little and you'll wind up somewhere down here. Okay, so we have left bound and right bound. And the calculator will tell you what the zero is. Okay, so here you can see my cursor is to the left of the zero, so I'm going to hit enter. Okay, and you can't see my cursor, but in order to be the right of the zero, my cursor is down here somewhere. You could tell because, see here I'm in the negative y values, so then I'm going to hit enter again. Okay, and then you're going to hit enter when it says guess, and now look, it'll tell you the zero, okay? The x value is approximately 2.06, right? This would round up to a 6. And what this means, this basically means y equals 0. If you see e to the negative 12th, this is negative 1.0, right? This e to the negative 12th is telling you to take that decimal and move it 12 spaces in the negative direction. So you're going to have 0.000000001, actually with a negative in front of that. So basically, that's equivalent to the number 0. It's so small that it implies it's 0. So it's crossing through the x-axis at 2.060. So the x value represents the time, so that's when it would hit the ground, at 2.06 seconds. Okay, number 12. Mrs. Paris gave her class the quadratic function f of x equals 2x squared minus 12x plus 9. All right, the question kind of got cut off here, but it says, state two different algebraic methods you could use to solve the equation f of x equals 0. Okay, so f of x equals 0. Basically, they want to know, when does f of x equal 0? So if we were to take this and set it equal to 0, since it's a quadratic, I mean, some of you might be thinking we could factor and make a t-chart and solve, but unfortunately this is not going to factor for us because there are no two numbers that multiply to 18 and add to negative 12. So two other methods we learned to solve a quadratic is number 1, the quadratic formula, and number 2, completing the square. Now, one thing I want to point out is it does say algebraic, so they don't want you to just use your calculator and solve. Okay, so the first method I said was the quadratic formula, so I'm going to start off using that. I'm just labeling off to the side here my A, my B, and my C. Okay, so let's plug it in. Now make sure you write x equals, because that's what we're solving for. So negative b, well, negative 12 would be positive 12, plus and minus the square root of. Now, if you write this, unfortunately, you're going to lose points, because you don't want to just square the 12 and then make it negative. You want to square the whole negative 12. So what we do is we just put the negative 12 in parentheses to show that we're squaring the whole thing. Okay, and then minus 4 times a, which is 2, times c, which is 9, and we're going to put that whole thing over 2 times a, so 2 times 2. Okay, so now x equals 12 plus and minus. All right, so if you want to figure out what we have under the radical, negative 12 squared is 144, and 144 minus, this is equal to 72, 144 minus 72 is 72. If you prefer to just plug this all in your calculator, you can do that as well. And then in the denominator, 2 times 2 is 4. Okay, now from here, please don't try to simplify this 12 and this 4. Okay, don't try to divide these by 4 because you can't, because there's a 1 in front of the radical. You have to be able to divide all the numbers by 4, and unfortunately 1 doesn't divide by 4. So what we do instead is we simplify our radical. All right, so you can break up radical 72. You want to come up with two numbers that multiply to 72, where one of them is a perfect square. Now, something I want to point out. There's a few different possibilities. Okay, so I made a list of, I made a list of all the perfect squares that multiply to 72. Okay, 4 is a perfect square, 4 times 18 is 72. 9 is a perfect square, 9 times 8 is 72. 36 is a perfect square, 36 times 2 is 72. Actually, I forgot one of them. 1 and 72, right? But anyway, you want to find the biggest perfect square that divides evenly into 72. Because if you don't find the biggest one, then you're going to have to simplify that radical again. So we're going to use 36 and 2. So you could write x equals 12 plus and minus. Now, we're going to break this up into radical 36 times radical 2. We're going to put that over 4. Okay, now since the square root of 36 is 6, I'm going to write this as 12 plus and minus 6 radical 2 over 4. Okay, now we're at the point. Now that we simplified the radical, we're at the point where we can look at our numbers that we have and say, all right, we have a 12, a 6, and a 4. What divides evenly into all of these? All right, well, 2. 2 divides evenly into all of them. So if I divide them by 2, the 12 becomes a 6. The 6 becomes a 3. Don't try to divide the 2 into the radical by 2. And then the 4 becomes a 2. So we get 6 plus and minus 3 radical 2 over 2. And that's your answers. If you want to branch it off and write 6 plus 3 radical 2 over 2, and then 6 minus 3 radical 2 over 2, you can do that. But I'm going to leave it at that. Okay, so the first method that I listed was the quadratic formula, and we did that. And then in part A, the second method we listed was completing the square. All right, so in order to complete the square, if you remember, you have to have a 1 in front of your x squared. So I'm going to go ahead and to get rid of that 2, I'm going to divide everything by 2 on both sides of the equation. Okay, so that leaves me with 1x squared minus 6x, and then plus, well, 9 divided by 2, 9 doesn't divide evenly by 2, so I'm going to leave it as a fraction. I'm going to leave it as 9 halves. And then 0 divided by 2 is just 0. Okay, now when we complete the square, we know we want to leave all the variable terms on one side of the equation. And I'm going to move this positive 9 halves to the other side of the equation, and when I do, it becomes negative 9 halves. So now I'm going to put an empty box on each side of the equation because I'm going to complete the square. All right, to find the number that goes in the box, you're going to look at the middle term. We're going to take half of this number and square it. So if I take half of negative 6, that gives me negative 3. And then negative 3 squared is positive 9. So don't just write 9 in the box. Make sure you write plus 9. Okay, we're adding 9 to both sides of the equation. Okay, so now when I factor the left-hand side of the equation, that's going to give me x minus 3 times x minus 3. And then when I add negative 9 halves, I'll do that off to the side, negative 9 halves plus 9, I'm just going to make that 9 over 1. All right, so I need to find, in order to add these, I need to find a common denominator, so I'm going to multiply the second fraction by 2 over 2. So that'll give me negative 9 halves plus, and then 18 halves. Okay, just multiply the top, multiply the bottom. All right, so negative 9 plus 18 is positive 9. And then keep the common denominator of 2. Okay, so that's what I get when I add these together. I get 9 halves. All right, now from here, whenever we have 2 of the same factor, we could write it once with a square in it. So I could rewrite that as x minus 3 squared. I'll bring down the equal sign, I'll bring down the 9 halves. Now what we're trying to do is we're trying to solve for this x, and it's trapped in the parenthesis with a square on it. So we first have to get rid of the square, and we know that we could do that by taking the square root of each side. So the square and a square root cancel each other out, so I could bring down the x minus 3. And on the right-hand side, this square tells us we could have a maximum of 2 answers. So I'm going to write positive and negative, okay? Positive is one answer, and negative is the other. And when we take the square root of a fraction, remember, we take the square root of the top and the square root of the bottom. So I could think about this as radical 9 over radical 2. Okay, so let me bring down the x minus 3 equals plus and minus. So now the square root of 9, that is a perfect square. The square root of 9 is just 3, so I'm going to write that as 3. And then radical 2, well, it's not a perfect square. 2 is not a perfect square, and radical 2 doesn't simplify, so I'm going to leave that as radical 2. Okay, now to finish getting x by itself, let's just add 3 to both sides of the equation, and that'll leave me with x equals this 3 plus and minus 3 over radical 2. So 3 plus and minus 3 over radical 2. Okay, so that is my answer. Okay, and one thing I do want to point out is I'm just going to slide this back over here. If we look at what we got when we did it through the quadratic formula, and then when we look at what we got when we did it through completing the square, these don't look the same. Now, if you think about this, if you were to take our answer here, if you were to do 6 divided by 2, that would give you 3. And then we have the plus and minus. Now, 3 radical 2 over 2. That doesn't look the same as 3 over radical 2. But let me just tell you, it actually is. We're going to learn something later on in the year. We're going to learn how to rationalize a denominator, which basically what we're going to do is we're going to get this to look just like this. I'm not going to worry about it here. We'll do that when we get into the radical units, but these two answers actually are equivalent. A really easy way to check is to just plug each of these in your calculator and look at what they're equivalent to in decimal form, and you'll see they are equal. See, so if you look, when I plugged in 6 plus 3 radical 2 over 2 and plugged in 3 plus 3 over radical 2, look, they were equivalent. And then same thing here when I plugged in with the minus sign, right? When I plugged in this with the minus and this with the minus, they are equivalent, so they equal out. Okay, letter C, it should say use, not using. Use your graphing calculator to solve f of x equals 0 for x to the nearest tenth. Now, I actually left these answers from part B up here because whether we do it graphically or whether we do it algebraically, if we're rounding to the nearest tenth, we should get the same thing. So we could see here to the nearest tenth, this would be 5.1. And then here to the negative tenth, this would be, to the nearest tenth, that would be 0.9. So when we do this using our calculator, these are the two answers we should get. Okay, so in your calculator, let's go to y equals and plug in this equation, plug in this function. And then if we want to figure out when it equals 0, we're going to go to second trace in the calculator. Okay, we're going to calculate the 0, so you could choose choice 2. Okay, now when you do this, it's going to have you put a left bound and a right bound around each 0. Okay, so what I did was I moved my cursor. See, here's the 0 I'm looking for. I moved my cursor to the left of it, right here, and hit enter. And then it said right bound, so then I took my cursor and I moved it down until I got to the right of this point and hit enter. And then it says guess, so I'm going to hit enter again, and let's see what I get for the 0. Okay, so look, here it is. And if you notice, this matches up with what we got when we did it algebraically. All right, so this first 0 right here is to the nearest tenth, 0.9. All right, so I'm going to put these in curly brackets. So the first 0 is 0.9. Okay, and then let's find the other one. Now, honestly, we already know from doing it algebraically that we're going to get 5.1. So I'm going to write that. And then I'm going to do it in my calculator, and I'm going to check. So I have to start again. I need to do left bound and right bound again, but this time I'm going to do it around this point. Okay, so I'm going back to second trace, and I'm choosing choice 2, which is 0. Okay, and since this is the 0 I'm looking for, I move the cursor a little bit to the left of it, and now I'm going to hit enter, and it'll have me find a right bound. Okay, so I kept moving my cursor to the right until I got to the right of it, and then I'm going to hit enter. I'm actually so far to the right you can't even see it. It's off the screen, but that's okay. And now I'm going to hit enter again until it says 0. Okay, and you can see that here it says 0, and it's when x equals 5.1, which matches up with what we got. And finally, number 12, the problem that I know you guys all love. All right, it says algebraically verify that this side of the equation is equivalent to this side of the equation. Okay, so let's go for it. So I'm going to start with my left-hand side of the equation, okay? If something is squared, it means we have 2 of them. So I'm going to take this and write it out twice. Okay, so now let's distribute. So let me distribute the a squared to all 3 terms. So when I do that, a squared times a squared is a to the 4th. A squared times b squared is a squared b squared. And a squared times c squared is a squared c squared. Okay, now let me distribute my b squared to all 3 terms. So b squared times a squared, just write it alphabetically, is a squared b squared. B squared times b squared is b to the 4th. And b squared times c squared is b squared c squared. Okay, now let's distribute the c squared to all terms. So c squared times a squared, again, write it alphabetically as a squared c squared. C squared times b squared is b squared c squared. And then c squared times c squared is c to the 4th. Okay, so now we want to combine like terms. Now, if you notice that this a to the 4th, this b to the 4th, and this c to the 4th, they can't combine with anything. And I'm actually going to line them up first, only because I'm looking at the other side of the equation and see how they come first. So let's do that. Let's group the a to the 4th plus b to the 4th plus c to the 4th first. Okay, now let's see what else we have here. So I have an a squared b squared. All right, as I look through, here's another a squared b squared. And it looks like that's my only a squared b squared. So I have 2 of them. So I'm going to write plus 2 a squared b squared. Okay, now I have an a squared c squared. So if I look ahead, oh, here's another one. So I can write plus 2 a squared c squared because there's 2 of them. Okay, and then finally, let's see, I have a b squared c squared and another b squared c squared over here. So since I have 2 of them, let's write plus 2 b squared c squared. Okay, now I'm going to do this a little different than what I see on the answer key, but than how I wrote it on the answer key. But if you look at this side of the equation, see how it says 2 times a squared b squared? And don't we have 2 times a squared b squared? And then we have 2 times a squared c squared, 2 times a squared c squared, and then 2 times b squared c squared. So if I want to get this to look like this, can I just factor a 2 out of all these terms? So let's do that. I'm going to bring down the a to the 4th plus b to the 4th plus c to the 4th, and then I'm going to factor out the greatest common factor of 2 out of these terms. So I could write plus 2, and when I do, I'm just pulling the 2 out of all those terms. So it leaves me with a squared b squared plus, and again, we're taking this 2 and pulling it out, so I could just bring down the a squared c squared, and we also took this 2 and pulled it out, so we would have plus b squared c squared. Now if you look, this side of the equation, the left-hand side of the equation, which started off like this, right, and worked our way down, now looks like the right-hand side of the equation. Now what we should do, and I'm not going to have room on the screen, but on the paper, you're going to have to write small and fit this. You would just keep taking this and bringing it down. So equals, and you would bring that down. Okay, equals, and you would bring that down. equals, and you would bring that down. And what you would notice is when you bring it down, the left-hand side of the equation equals the right-hand side of the equation, so you can put a check. Okay, you verified that the left-hand side equals the right-hand side.